This is a skyscraper built in the United States over 100 years ago. Early elevators were only fixed by a single rope, which could cause severe safety accidents if it broke. In 1853, a mechanic named Otis finally invented an anti-fall device. He first added guide rails on both sides of the elevator, then fixed truck springs at the top and connected them to gear tracks on both sides of the rails. If the unfortunate event of a cable break occurred, the tension-free springs would instantly release metal wedges on both sides, locking directly into the rails, thus ensuring the elevator's operational safety. Shortly after, engineers began attempting to build higher floors, but since early materials were mainly stone, when the building's main height exceeded 80 meters, the overall weight would exceed the stone's limit, causing subsidence or even collapse. To address this, engineers directly replaced the stone with lighter and stronger steel beams, then hung thin brick and stone walls on the steel frame like drawing curtains. The successful application of steel structures truly propelled the development of skyscrapers. Glass curtain walls also started to become popular at this time, although they provided excellent light. However, in the hot summer, they could not block the high temperature, making the interior feel like a sauna. In 1901, engineer Kelly invented a unique cooling system, which was the prototype of the first air conditioner. First, cold water was continuously sprayed into the machine, making the internal air humidity reach 100%. When the hot and humid air was sucked in, it collided with the cold water mist, cooling the air and releasing moisture onto the water droplets, making the machine's interior very cool, which was then continuously delivered to the building. As skyscrapers continued to rise, construction speed became a significant issue. To shorten construction periods, engineers devised a special method. Building components were now prefabricated at the construction site and then transported to the site for assembly. However, since the components weighed over 50 tons, lifting them became a big problem. To solve this, engineers installed cranes at the base, lifting reinforced steel structures one by one into pre-installed special molds, pouring in concrete, and waiting 12 hours for it to solidify. Then the hydraulic jacks at the base could push the tower upwards. The brackets were then recovered, and the buckles were locked. In this way, the tower crane continued to rise with the building height, thus constructing the skyscraper. This method not only reduced costs, but also saved time. As skyscrapers were built higher and higher, the steel structures started to feel inadequate. Wind speeds around the top floors could reach 80 kilometers per hour, causing the entire building to sway, making it difficult for people inside to work or live. To counter this, engineers came up with a clever idea. They moved the previous internal steel structure to the exterior and reinforced it, effectively resisting strong winds. At the same time, skyscrapers also needed to withstand powerful earthquakes. Therefore, engineers erected 36 hollow steel columns in the center of the building and filled them with concrete, forming an integrated steel-concrete structure. The exterior adopted a segmented design, with every 8 floors as a group, using elastic steel beams directly fixed to the building's outer wall. Even in strong earthquakes or typhoons, the structure could absorb energy through twisting and stretching, thus ensuring the building's safety. Through continuous technological breakthroughs, the Burj Khalifa was finally completed on January 4, 2010. With a height of 828 meters, it has 53 elevators and a total of 169 floors. It is currently the tallest building in the world and a testament to human civilization and wisdom.